I'm expecting this to be in your chemistry exam. This is redox reactions and half equations. They are nowhere near as bad as you think. Say it with me, this is light work. So what is a redox reaction? It's one that involves both reduction and oxidation. Think oil rig. Oxidation is loss, reduction is gain of electrons is what we're talking about. So with these you can be asked to write half equations because they show you half of the overall reaction, either just the reduction or just the oxidation. We're going to look at a couple. My first example is chlorine. Remember some fundamental knowledge. Electrons, they're negatively charged. So something in group 7, what kind of an ion would it form? Well, if it's in group 7, to get its full outer shell, it's much easier for it to gain 1 electron than trying to lose 7. So if it gains 1 negative electron, the charge of that ion is going to be 1 minus. So the half equation pretty much is just making this ion go back to being a normal atom. You just need to undo what happened to make it become an ion. So like we said, this is negatively charged because it gained that 1 electron. So what needs to happen is it needs to detach from that electron to become normal chlorine again. So start by doing this. Show that this chlorine ion will detach from its electron to become normal chlorine again. But you need to remember, guys, chlorine doesn't go around as a Cl. It's a diatomic molecule, which means it has 2 atoms. It would be Cl2. With that, we're going to need to balance this half equation. So if you have 2 Cl atoms, we needed 2 Cl ions. Also, remember, each of those ions had 1 electron to get rid of. So we need 2 electrons here that we needed to have gotten rid of. And there you have it. Chlorine has been discharged, and that is your balanced half equation. And quickly, whilst we're here, since this has lost its electron, this was an example of oxidation. Let's do another. Magnesium. Start with the ion. So magnesium is in group 2. How would it form an ion? It would lose 2 electrons. And if you lose 2 things which are negative, your charge will be 2 positive. So what does this need to do to go back to being normal magnesium? Well, to cancel out that positive charge it has, it would need to gain back those electrons. And how do you show something in a chemical reaction being added to something? Well, of course, you put it on the reactant side of your arrow. And then we've produced magnesium. But just double check, is this balanced? We had an Mg2 plus here, so it needed to gain 2 electrons, not just 1. So chuck a big 2 there, and this is all sorted. Also, since we gained electrons here, this would be reduction. Okay, here's a tricky one. Oxygen, try your best to form the half equation. Sweet, so how does oxygen go back to being normal oxygen? How does it get rid of that negative charge? It would need to lose electrons. And we show that, like we did with the chlorine, it will start off as the ion, and then on this side of the arrow, it will detach into oxygen and the electrons. But does oxygen go around as an O? Hell nah! Oxygen is diatomic as well. This would be O2. And you need to make sure, therefore, that this is balanced. If we have 2 atoms, we needed 2 ions. And each of these 2 ions had a 2 negative charge, so we needed to lose 2 electrons